Let's look at OpenStax College Physics, Chapter 14, Problem 22. To help prevent frost damage, 4 kilograms of 0 degree Celsius water is sprayed onto a fruit tree. A. How much heat transfer occurs as the water freezes? B. How much would the temperature of the 200 kilogram tree decrease if this amount of heat transferred from the tree? Take the specific heat to be 3.35 kilojoules per kilogram Celsius degree and assume that no phase change occurs. All right, let's write down our knowns and unknowns. So we know that we have M water is 4 kilograms and the temperature of the water is 0 degrees Celsius. And we're looking for the amount of heat transferred as the water freezes. And then in part B, we're told that the mass of the tree is 200 kilograms and the specific heat of the tree is 3.35 times 10 to the third joules per kilogram Celsius degree. And in part B, we want to know the amount of the temperature change, the decrease in temperature, if that heat was transferred from the tree. So I have a place for the diagram, but I really don't have much to draw on there, so I'll skip that. So we know that the heat necessary for the water to freeze is the mass of the water times the latent heat of fusion for water. And we know that that same heat, if provided by the tree, that would correspond to the mass of the tree times the specific heat of the tree times the change in temperature of the tree. So if these two quantities are the same, so QW equals QT, then mass water latent heat of fusion equals mass tree specific heat of the tree times delta T. So we're solving for delta T, and that will be mass of water latent heat of fusion divided by mass of tree specific heat of tree. So that is 4.00 kilograms. Latent heat of fusion for water is 33.5 times 10 to the fourth joules per kilogram degree Celsius. And we divide that by 200 kilograms times 3.35 times 10 to the third joules per kilogram degree Celsius. And when we plug these numbers into our calculator, we end up with 2 degrees Celsius. So the temperature of the trees would decrease by 2 degrees Celsius.